Good evening, everyone. In the last videos, we have seen very clearly about DQ implementation by using arrays. Okay, how to implement double-ended queue. Okay, how you can implement double-ended queue by using arrays. We have seen very clearly in our last videos. Okay, now in today's session, related to the same DQ, double-ended queue, we need to talk about DQ implementation by using linked list. Sir, how you can implement this by using linked list? Sir, I will explain the program related to this. Have a look once. So for this purpose, I'm taking a special class called DQ. Okay, DQ list. And what are the required pointers, sir? We need 2 pointers. One is to point to the front, another one is to point to the rear. And integer, I am going to represent count, or you can take size, which represent so the number of elements in DQ. Okay, like this we have. Now I am writing a constructor. Inside this constructor, the value of front is initially null and the value of rear is initially null. And initially, how many elements are there in the queue, sir? Only 0 elements are there. Next, sir, what is the structure for this node? We have to define, right? Class, I am taking a node. In this node, we have data field is there, and then node next field is there. Okay, so node integer, I am taking data field, and then I am taking next field. So current data field will become the data field. So current object next field will become next object. Like this we have. This is nothing but the data which is required if we want to work with DQ by using linked list representation. So these are the entities which are required for doing this operation. Can you please confirm, is the structure of this linked list representation, is it clear for everyone? Yes, please confirm. Right. Now we need to talk about the methods. Okay, we need to talk about the methods. Sir, one by one method I'm going to demonstrate now. So let us see how it is going to work. So what is the first method? Sir, I want to insert node at very beginning, sir. I want to insert a node at very beginning. So what is the function? I am taking insert at front, which is taking some value. We need to insert this value. Okay, I will create a new node. So with this given value as a data, and the next field will become null. Suppose if your front is equal to null, means what? My linked list is empty. My DQ is empty. We don't have any elements in this DQ. So in such cases, what will happen? Whatever node that you have created, that new node will become front node. At the same time, that new node will become rear node, and then size plus plus. Okay, size plus plus. I think better you can write this size plus plus here, right? So now it is going to be incremented and it will return. That's all. Sir, my front is not equal to null. Some nodes are there. Okay, I will explain clearly with the help of diagram. Have a look once. Sir, initially, so my front and rear both are pointing to null, sir. Both are pointing to null. We don't have any object now. So I want to create a new node. This node will become new node. So what is the content here? The content is a 10. Next field is null. Okay. Sir, what about your front? It is null. What about your rear? It is also null. If a front is equal to null, what is the meaning of this? In this DQ, we don't have any elements. This is the newly created element. This will become front and this will become rear and this will become new node. Like this we have. Sir, now I want to call one more time insert at a friend. Sir, here only the object will be created, right? Sir, now what will happen? This will become new node. Now this link is gone. Sir, consider the data is 20 and the next field is null. Is your friend is equal to null? No, because the friend is pointing to something. Sir, what we have to do now? So the condition is not satisfied. It will come out from the if. Very simple instruction. New node next field will become friend and your friend will become new node. That's all. Only two instructions. Have a look once. Sir, new node dot next will become friend. New node dot next will become friend. Now this will become your friend, sir. Okay, this will become your friend, right? This will be gone. Clear, right? Now friend is pointing here, rear is pointing here. Sir, I want to insert one more node. No problem. You can create one more node like this. So with next field as a null, this will become new node. This will become new node and the content is nothing but consider 15. Sir, is your friend is equal to null? No. Then new node tends to next. This next field will become friend and this will become your friend. Now friend is this one, new node is this one. These two will be gone. So friend is pointing to this node, rear is pointing to this node. Okay, this is the way how you can perform insert at a friend. Okay, insert at a friend. Sir, okay. Suppose if I want to insert at ending, what we have to do? Same step only, right? I want to insert at ending. Sir, now here I want to insert. Consider this is nothing but my new node. So here I want to attach. So if you want to attach here, this will become your new node, right? So consider the content is nothing but something like 40. How you can able to attach? Have you observed? This rare is there, right? Its next field will become this one and this will become rare because we are inserting at ending. Rare pointer should same operation, right? Now I will rewrite that function. Void sir insert. Okay, insert at rare. So we have some value is there. So I'm creating a new node is equal to, so new node of, I am passing the value and the next field as a null. Okay, next field as a null. Suppose if your friend is equal to null, as usual case, sir, what will happen? Your friend will become new node, your friend will become new node and your rare will become new node and then return. Otherwise what we have to do? Already rare is there, its next field is pointing to rare and then your rare will become new node. Like this I am teaching. Okay, so this is nothing but the simple explanation for this. Okay, I think you people got a clarity about how you can able to perform insert operation on dq, that is in the beginning as well as it is at the ending, sir. Okay, can you please confirm, friends, is this insert operation, is it clear for you people, guys? Yes, I request everyone to please respond. Is it clear for you people, guys? Right, sir. Now my requirement is I want to insert, sorry, I want to perform delete operation. Okay, so void delete. Okay, delete at first. How you can able to delete at first? Similarly we have to write, so delete at last, that means delete at rare. So better you can use a delete at friend, that will be good terminology, right? Like this I am taking. Okay, rare dot next is equal to new node, or rare dot next is equal to rare I have written, right? No, rare dot next is equal to new node. Pradeep, correct. Sorry. Okay, rare dot next is equal to new node and that new node will become rare. Thank you. What about remaining people? So you have not noticed that. Okay, I request everyone not only just blindly listening the class, you need to concentrate on the internal parts also. Okay, like Pradeep sir. Okay, right. Yeah, sir, now we have to see delete at the front, sir. Sir, how you can able to delete the node at the front? Have a look once. Sir, I have already certain nodes are there in my DQ. Consider this is nothing but my first node. Okay. This is nothing but my second node. This is nothing but my third node. And this is nothing but my fourth node. Like this, we have some nodes are there, sir. So this node next field is nothing but this one. This node next field is nothing but this one. So this node next field is nothing but this one. Its next field is null, and this is a rare, and this is nothing but friend. So 11. So I have 22 and 33, and I have 44 is there. Now, so I want to talk about delete at friend. What we have to do? Sir, if your friend is double equal to null, means what? My DQ is empty, right? In such cases, I am printing the message saying, boss, my DQ is empty. I can't able to delete. Simply written. Otherwise, what will happen? Very simple. System dot out dot println of array boss. Your deleted object is. Which object is deleted? Since we are deleting from the front, so front dot data you need to print, and immediately your front will become front dot next. So let us execute, let us mark with the help of some color. Sir, this is the front, right? Is it front is equal to null? No, deleted object is 11. Now we are taking front is equal to front tends to next. Now onwards front is pointing here. So this is our new list or not? Yes, very simple operation. Similarly, delete at rare also. Okay. Size minus minus, correct. Here we have to perform size minus minus. Yeah, Pradeep, I have updated. Okay, sir, delete at rare also same, right? What we have to do? Suppose if your front is equal to null, then what is the meaning? My DQ is empty. Okay, so my DQ is empty. Like this we have, and then return the control. Otherwise, system dot out dot println of, sir, here also the deleted object is, which object is deleted? So plus I have to take rare dot data because last item, right? That's why. But directly you can't be able to perform. Okay, directly size minus minus also I will take. So directly you can't delete this node because see, remember carefully one small hint, sir. When you want to delete a first node, it is very easy because first node next field is pointing to the next node. So we can break that link by making front is equal to front dot next. But we want to delete this rare. It is a single linked list. Rare tends to next is there, but rare tends to previous is not there. That's why what we have to do, you have to take this front as a tool. You need to move to the ending until you are getting rare. Okay, observe my point. Okay, so now what we have to do here, I'm going to write a condition. Okay, up to this I will take a screenshot. Now I am writing a condition. What is that condition? Array boss, if your front and rear both are pointing to the same node, when this situation will come, when you have only one node in the list, in such cases your front will become null, your rear will become null. Like this we have, and then simply return the control. Sir, otherwise what will happen? I am taking one temporary node which is pointing to the front. So while your temp dot next is not equal to rare, while your temp dot next is not equal to rare, so your temp will become temp dot next. You have to keep on moving the pointers. Okay, now observe carefully. Sir, this is nothing but my temp initially. Temp is equal to front. Is a temp tends to next. Is it rare? No. Then your temp will become temp tends to next. Sir, while temp tends to next is not equal to rare. Sir, here it is rare. So rare pointer is there. Previous node also we got. Now you can break this link very easily because we have a control on this node. Now, how to do that? Come out from this while loop and I am taking rare is equal to temp. Rare is equal to temp. And rare dot next will become null. So rare is equal to temp. That means what? This node will become rare node. And rare tends to next is equal to null. Null means this node is gone. This is nothing but the latest nodes which we have. This is a front and this is a rare. Okay. This is the way how you can able to perform which operation? Delete operation from the beginning and from the ending. Okay. I think you people got clarity about these two, sir. Can you please confirm any doubts up to this? Vishal, you have one doubt, right? What is the doubt? One second. Maybe you have asked this doubt in the delete front. So see, if you have only one node is there, if you have only one node is there, front is pointing this one, rear is pointing this one, right? So if a front is equal to null, no. Sir, front will become front tends to next. Front will become front tends to next. What is a front tends to next? Null. So automatically your front will become null. Okay, clear? In the delete at rear, we have to check because front and rear are in different positions. Right. So now the last operation, of course, whatever task we have done till now, so we need to execute, right? For that compulsory, this function is required. Okay. Sir, if your front is double equal to null, then I'm going to display a message saying, sir, my DQ is empty. Then return the control. Otherwise, what we have to do? Node I'm taking temp, which is pointing to front. Node I'm taking temp, which is pointing to front. So while your temp is not equal to null, while your temp is not equal to null, we have to display the data. System.out.printf. So temp dot data. Okay, and next some space. After that, your temp will become temp dot next. And at last, I am printing system.out.println. That's all. Now it is going to display all the elements. I think no need to explain, several times we have seen this. Now I need to execute the code. Sir, DQ list, DQ is equal to new DQ list I am taking. Okay. Now DQ dot, let us call display function first. Sir, what message we are getting? It will display a message saying my DQ is empty. Java C test.java I am taking. Code compiled fine. Java space test. You can see my DQ is empty. Sir, I want to insert DQ dot. So insert at front. Okay, I have inserted 111. Otherwise, let me take 333. So DQ dot insert at front. I am taking 222. So DQ dot insert at front and I'm taking 311. Now, if you display, what is the first node? 311. Next node 322. Next node 333. Because, sorry, yeah, correct. Because first we have inserted 333. Then insert a front. So at the beginning it will insert. Insert a front. Again at the beginning it will insert. Let us cross check whether we are getting these three values or not. Yes. Now I want to insert at end. Okay. Now I want to insert at end. Okay. So 1 second, sir. Please wait. Right. Now we will see how to perform at delete. So dq dot I will insert at rare 444. Sir, where that element will be inserted? Already 111 is there, 222 is there, 333 is there. So here that 444 will be added. If you want, let us cross check. Yes. Sir, now I want to insert dq dot insert at rare. Again, I want to insert 355. Sir, where it will be added? Here it will be added. If you want, you can cross check. Sir, I want to insert at beginning. No problem. Insert at front, you can call 999. Where it is going to be inserted? At beginning. Now let us cross check. Yes. Now I want to delete one node from the beginning. First, I want to delete one node from the beginning. Sir, what we have to do? dq dot. So delete at front. Then immediately after that, if you display, so you are going to get only this particular content. If you want, let us try. Deleted object is 999. That content is not there. Now I want to call delete at rare. Delete at rare. dq dot. So delete at rare. Sir, what will happen? It is going to remove 355. If you want, you can cross check. Have you observed that 355 got removed? Now onwards, that 355 is not there here. This is nothing but how you can able to implement DQ by using linked list. I think normal queue implementation with by using arrays and linked list. So next circular queue implementation by using arrays and linked list. So next and after that DQ implementation by using arrays and linked list. These programs are clear for you people, I think so, right? Can you please confirm? Do you have any doubts, friends, up to this? I request everyone to please respond. Any doubts up to this? Clear? I request everyone to please respond. Clear up to this? Right. How can you use this for other data types like string? A good question. How you can use this for other data types like string? No problem. The only change what you have to do is where we are storing the data. This data type you have to change. Okay. So here also you need to take a string. Okay. And here also you have to take a string. Next and after that here also you have to take string. That's all. And now you can insert. You can insert of insert front. Sir, I am taking K. So insert at rare. Insert at rare. Sir, I am taking Prakash. Okay. So I want to display the content. So what answer we are getting? K Prakash. Okay. So otherwise, let me take something like ABC. Otherwise, let me take Java. And here I am going to take Python. So what output we will get? So Java and Python. Okay. So now I want to add DQ dot insert at front of, I want to insert DSA Java. So now this DSA Java will be added at the beginning. Okay. Clear? Your doubt got clarified, I think so. Swapnil. And even you can use for student object, anything you can store, no problem at all. Okay. For all other implementations are same. Yes. The only thing is data type is going to be changed. If you want, you can store student objects also. Okay. Right. That is the data structures, man. Why you people are getting confused? Okay. Right. Sir, almost everything almost related to the queues got completed, except one small thing is there. Let me finish max by today, otherwise tomorrow. Sir, predefined, predefined queue implementation, predefined queue implementation. Sir, Java people defined collections, right? In that, there is one predefined class is there with name, predefined interfaces are there with name queue. Sir, here, what is this queue? We have collection is there, right? Is it an interface or class? Interface. The most commonly used objects will be there in this collection. The most commonly used objects will be there in this collection. Okay. Most commonly used methods. Now I am taking one of its child class is nothing but a queue, sir. It is also an interface. For this queue interface, we have one priority queue is there. It is implementation class. Okay. So priority queue is there. It is nothing but implementation class. Similarly, for this queue, we have one more implementation is there. One more class is there with the name blocking queue. It is an interface. Of course, for this we have child classes. As of now, it is not required. Sir, for this queue, one more interface is there with the name DQ. Okay, DQ. It is also an interface. So the main is nothing but the collections. For this collection, one of the child interface is queue. We have list interface is there, set interface is there. Like that, one of the interface is nothing queue. For this queue interface, we have three child classes. Sorry, three child roots are there. One is a priority queue. It is a class. Second one is a blocking queue. It is an interface. So DQ, it is an interface. I am not going in detail. Just I want to talk about only two things. How this queue is going to work, how this DQ is going to work. Okay. So here, if we want to represent, okay, if we want to represent a group of individual objects, a group of individual objects prior to processing. This is the terminology which we have to use. Prior to processing. If you want to process prior, so then we should go for queue concept, sir. Okay. So, and it is child interface to collection. It is a child interface to collection. Like this we have. Prior to processing means what? Sir, which one has to get a first chance? For example, in a queue, 5 members are there. The person who came first. So we have to give highest priority for that person. Suppose when you are standing on the queue, one cinema hero came. Then what bank people are going to do? They will give first priority to that hero. What is the reason? Because if hero stands on the queue, what will happen? Crowd is going to be increased. So many people are going to take selfies. Okay. Some disturbance will be there for bank people. N number of issues will be there. So they are next level people. So what we have to do? We need to clear their job first and then we have to send them out. Okay. So that cases are called as priority queues. Sometimes we need to block. For example, you are standing on the queue. Sir, you are in some 50th person. You are. Sir, queue started from 1. Okay. Up to 49 completed. When it comes to your turn, sir, you are going to submit the application. In that application, there is one small correction is there. So what the people are going to tell? So you need to make the correction. So and then you have to get back. Sir, once if you make the correction, again, are you going to stand it in the queue? No, because again 100 members will be there. You need to sit at the last. So when you are going to get your turn, maybe at the middle of the day. Again, if you have a mistake, till the complete day, you need to spend on the queue. That's why there is one separate queue they are going to maintain, which is called as a blocking queue. Okay, they are going to maintain a separate queue called blocking queue. And DQ is there. Sir, for example, three days back, last Saturday, Sunday, I visited my famous, my hometown famous temple, Tirumala, TTD. You know very well. Sir, in that, so we have purchased 300 rupees token. Sir, they have opened the gate exactly at morning 2 o'clock. Okay. And they asked the what you can call persons to enter into that queue, and then they have stopped at the very beginning itself. Sir, why they have stopped? Up to certain strength they will maintain that queue. Sir, around 300 to 400 members are there. Immediately they start to open the gates. Then all the people are enter into the gate. Still the gate is going on. Now this gate is divided into three parts. So we have three divisions are there, three paths are there. So this first path is going like that, second path is going like that, third path is going like that. Sir, this first path, they are merging with another queue at the very beginning. Okay, normal people will be there, right? So they are going to merge that queue with the ending. Have you observed? Insert at the beginning, insert at the ending, such type of principles will be there on that DQ. So whenever we are implementing these kind of queues, you required these three types, sir. I think more than this, no need to give anything. Okay, directly I will go with programs. Can you please confirm, is the intro to this collection and then this queue, predefined queue implementation, is it clear for you people, guys? Right. Now, sir, first I want to talk about queue interface. Sir, what is mean by this queue interface? Few points are there. The very first point is it is introduced in 1.5 version of Java. Sir, it is not there from the beginning. We don't have this queue concept from the beginning. It is added at 1.5. Next and after that, it is child class to collection. It is child class to collection. For collection is there. So this one is nothing but a child class to this collection. And it is not index based. Of course, index terminology is there, but it is not index based. And it is going to allow duplicate objects. If any duplicate object is there, it will entertain. There won't be any issue with that. And it will allow all the elements. It will allow all the elements. So prior to processing. Next and after that, which structure it is going to follow? FIFO, first in first out structure it is going to follow. Sir, what type of objects it is going to insert? Sir, it is going to insert only homogeneous. Okay, homogeneous. Homogeneous means what? Same type of objects it is going to allow. Same type of objects it is going to allow. For example, if queue is there, compulsory human beings should be there in the queue. So you can't keep your kerchief, or you can't keep your bag and then you can stand there. So whenever your turn come, you can come and join. Such type of things are not allowed here. Compulsory your presence is required. Okay. Next and after that. So null values are not allowed. Compulsory person should be there. Compulsory object should be there. And all these things should be comparable objects. Only comparable objects are allowed. Example for comparable objects. Sir, can I take two integer values and then I can compare? Yes, you can compare. Which one is the smallest? Which one is the largest? You can compare. Sir, can I take two floating point values for comparison? Yes. Can I take two characters to compare? Yes. Can I take two Boolean values to compare? No. Can I take two string objects to compare? Yes. Can I take two student objects to compare? No, you can't. Can I take two customer objects to compare? No. But sir, in the customer, some ID number is there. I want to process my queue based on that ID number, or I want to process students according to the age group. Then I need comparison. How I can do, sir? Then you can go for customized comparison. So if you want, okay, non-comparable objects, so then so we should go for, which concept, sir? Java dot util dot, there is one predefined class is there with name comparator. You have to use this comparator for doing all such type of comparisons. So anyway, maybe you have heard about that in your collection. If not, we don't have any time to revise that comparator, comparable, all these things. I'm going to stop here itself. Okay. Sir, please confirm, is this a few points related to the Q? Is it clear for you people? Is it clear for you people? Right. Anyway, I want to talk about a few methods. Okay. Uh, yeah, I want to talk about a few methods related to this Q, sir. Sir, what methods are there? Very simple. I want to add an object. Sir, which method we are going to use? Offer method, which will take an object and what it is going to do. So it is used to add an object into Q, sir. Sir, I want to add this object. Let us take one example for this method. Sir, clear, but array list and linked list allow heterogeneous objects. Why not Q? That's what I am explaining. VN. See, if you have two objects are there, what is the purpose of this queue? We are going to process that queue. Okay, when you are processing, all the elements should be of same type. Okay, I want to store integer values. So consider that integers are nothing but priorities. So if you store a string value in the middle, it won't entertain because internally some algorithm is followed for that. Heap trees priority queue is going to follow heap tree data structure. There compulsory the elements should be of same type. Clear? But in the case of array list and linked list, is not going to follow any such type of order. Array list is same as array. Okay. So there we have to use some generics concept to do that. Even in the set also, we are going to store only same type of objects. Clear? VN. Right. So I need to demonstrate this offer method. So till now we have implemented our own concepts. Now onwards, we are going to enjoy the predefined tools. Now let us see. So I am taking Q. So Q is equal to, you can't create object for Q. Why? Because it is an interface. That's why I am taking priority Q. Priority Q. Sir, I want to display the elements. So system.out.println of system.out.println of I am printing Q. Empty Q, right? Empty Q. Okay. Now I want to add certain objects. I want to add certain objects. Now let us add Q dot. What method we are using? Offer. Offer of I am taking 111. So Q dot offer of I am taking 222. So Q dot offer of I am taking 333. Sir, is these objects will be added or not? First in, first out. So like this it is going to add. Let us compile. Sir, can I insert Q dot offer of? Can I insert triple A? Let me check how it is going to work. Sir, have you observed class cast exception? Java dot lang dot integer cannot be casted to Java dot lang dot string. Okay. So like this, we are going to get, there is some problem with comparison. Okay. Like this we have. So this is nothing but what we have. Sir, can I insert null values? Can I insert null values? I think so not, because we can't compare, same reason. Null pointer exception we are going to get. So this is nothing but what we have, how you can able to add. Okay. If you want, I will show you one more example. Sir, I am taking new string of triple A. Okay. So I want to hold new string of triple B. Sir, I want to hold new string of triple C. So is the code is going to compile? Yes. Is it going to execute? Yes. Now in the place of a string, I am taking string buffer. Okay. In the place of string, I am taking string buffer. Now see what will happen. Oh, it is coming. Maybe string buffer is also comparable. String buffer is comparable. Java p java dot lang dot. So string buffer. No, it is not coming Java p. Maybe string buffer is comparable. I think so. Otherwise, okay, I will do one thing. I will take one demo class. Okay, I will create new demo object. Okay, like this, I'm creating second object. Like this, I'm creating third object. Okay, now is it possible to add? Have you observed? Class demo cannot be casted to comparable. Have you observed? It is having a problem. So if you want to do this, then this class must implement java.util. Comparable interface. Then you can able to insert. But again, we are going to get one error message saying demo is not abstract, does not override abstract method. Have you observed which method they are expecting to override? Compare to method. Compulsory you have to write. Then only I can able to support. Okay. Right. I think you people got a clarity. At least you got some new points in today's session. Can you please confirm, is this the first method, offer method, how to add the object into the queue? Is it clear for you people? String buffer implements comparable but does not override equal. Maybe. Swapnil, correct. I request everyone to please respond. Is these concepts are clear for you people, guys? Right. So that's all about today's session. Remaining things we will discuss tomorrow. Sir, one more small information from tomorrow, our classes. Class timings are changed. Class timings are from 7 p.m. to 8 p.m. Okay, from tomorrow, our classes will be there from 7 p.m. to 8 p.m. Okay, please keep it in mind. We have classes from 7 to 8. Okay. Right. I request everyone to please log in at 5 minutes before. Exactly at 7 I will start. I will wind up at 7:50 like that. Okay. Right, sir. Thank you. See you from tomorrow. Okay. Thank you, guys.